Good morning. In this video, we're gonna solve a practice problem under the time, velocity, and speed section from OpenStax College Physics. Okay, so let's start. The planetary model of the atom pictures electrons orbiting the atomic nucleus, much as a planet orbits the sun. Okay, so essentially you could think of it as what? There's a nucleus here, red, and there's a what? And for this problem, it's like it's a hydrogen atom, and a hydrogen atom only has one electron, okay, and one proton in the nucleus. So this electron will orbit the nucleus in a certain distance, and if we are given that this distance here, the diameter, the diameter of the orbit is 1.06 times 10 to the negative 10 meters, and the average speed is given. The average speed of the electron in this orbit speed, the average, is equal to 2.20 times 10 to the 6 meter per second. And we are asked here for part A to calculate the number of revolutions per second it makes about the nucleus. Now, note here that number of revolutions per second. So we're asked to find how many revolutions will this electron be able to make in 1 second time around the nucleus. Now, to work that out, let's just remember that, okay, for this is for part A, that speed is just essentially distance over time, okay? Distance traveled over time. And note that here, we're given speed, yes, okay, so let's try to plug it in. 2.20 times 10 to the 6, okay, meters per second. And the time here in a 1 second, so we're given for 1 second. So from here, we can solve, most likely, we can solve for the time. Okay, so from this setup alone, I mean, we can solve for distance. I mean, we can solve for distance. How far will be the electron be able to travel? Meaning distance traveled in electron in a certain time of 1 second. Okay, this is times 10 to the 6. Okay, meters per second. Okay, so in 1 second, in a period of 1 second, the electron will be able to travel. Okay, this is meter per second here. So if you multiply 1 second both sides, we will be getting 2.20 times 10 to the 6 meters. I mean, that's the distance that the electron could travel in 1 second time. And now, what we are not being asked for the distance in this problem, but we are asked for the revolutions will it be able to make, because this electron will just be rotating or revolving around the nucleus. So if that will be the case, then let's think about it this way. One revolution, okay, one revolution. Note that one revolution is that when the electron completes a revolution, it will be able to travel a certain circumference, right? And it's equal to 2 pi r. I hope this is familiar already, because a circle, the perimeter of the circle, the circumference of a circle is 2 pi r. Okay, so for this case, one revolution is equal to 2 pi. Let me see, 2 pi 2. Okay, 2 times pi is here, times r. What's the radius? It's 1.06 times 10 to the negative 10, but this is diameter, so we divide that by 2. Okay, let me multiply that again. 1.06 exponent negative 10. Okay, exponent negative 10 here. Okay, and I divide it by 2. Divide by 2, because that's not the radius. Okay, so I'm getting a what? Per revolution, that's 3.33. Okay, I'll use that. 3.33 times 10 to the negative 10 meters. Okay, meaning one revolution will be equal to that. Okay, so meaning in a period of 1 second, it's able to travel this distance. And note that one revolution is equal to this distance. So we can just find the number of revolutions here. Number of revolution. Okay, in a period of 1 second, it's equal to 2.20 times 10 to the 6 meters times, we note the conversion that for this case, one revolution, okay, is 3.33 times 10 to the negative 10 meters. Okay, because when this electron completes one revolution, it's able to travel that distance. Okay, I hope you're not that confused. So 2.20 exponent 6 divided by 3.33 exponent negative 10. Okay, and we are getting, oh, this is quite a big number. How many zeros will this be? 1, 2, 3, I mean, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I mean 15. So it will be what? 6.6, 6.61 times 10 to the 15 revolutions per second. Meaning, every second it's able to what? To revolve around the nucleus this much, this times. Quite a very big number. Okay, but that's of course the electron is moving too fast. It's what it's That's why electrons cannot really be uh, it's it's what this speed is quite very fast. So we're expecting also that it will be able to revolve around the nucleus that many times a second. So now how about part B? Part B is asking for um electron's average velocity. So V average. Now the average velocity is simply what? Displacement, total displacement over time. Now in here, since the electron is just moving around a circle, we can simply assume that, well, for one complete revolution, the displacement is zero, and for a certain amount of time. Okay, so because of that, displacement of zero means uh, there's no displacement. So average velocity for this case, since the electron is just moving along a circle, meaning the electron is not really moving anywhere. It's just rotating. So average velocity will tend to be zero. Okay, if we assume that it starts from here and during that time that it completes one full rotation. Okay, thank you.